Grüezi miteinander. Hey, at least I have a Swiss friend here. Sorry, that's kind of a bit of a joke. I live in Switzerland. But hello, welcome everybody for the latest edition to JCON Europe. And we have this is an interesting topic today. It's called Going Beyond ORMs. And I do know that there are some people in the audience that like to work with ORMs, and there are some others that do not. So let's raise some hands. Let's see how many people really like working with ORMs, regardless of what it is. Okay, it's like 20%, and so the other people don't like to use ORMs? Kind of, 30%? We'll see. Okay, so the idea of this session is to showcase a feature that is available in the latest version of the Oracle database. That it's the way that it's presented, the way that it is thought of is so that you don't necessarily have to deal with heavyweight ORMs. We're not saying, oh, let's kill the ORM, we're doing the best next thing. Actually, you can combine both in some way. So we'll see in just a moment. So my name is Almiray. I'm a Senior Principal Product Manager at Oracle. And one of the things that I like to do, well, I'm sort of Java developers. That's the reason why I'm here. I like to talk to developers. I like to talk about the different projects that we have at Oracle, but also open source in general. Now, here's the agenda for today. We're going to have a look at what is the current state of relational data, so what is good, what is bad about it. They're also going to turn into documents, so JSON documents, and what is good and what is bad. And then we'll find a way, if it's possible, to combine both of these kind of formats and both of these ways of working together so that we can get better results. Then that's this feature that we have called JSON Relational Duality. I will do a demo of this technology, and then I guess we will still have time for some questions. So I should say also, whenever you have a question, just raise your hand. We don't wait until the end. So of course we're going to talk about the Oracle database. So most of you have heard of the database product. Some of you have made use already or have encountered it, maybe thinking of using it, or some may be thinking of just migrating away to another database vendor. Now, one of the things that I like about the Oracle database is that it is one of those products that or database engines that can host as many formats under the same roof. So say that you have Postgres and you have MySQL and you have Mongo and you have Neo and the other vendors for the different formats. You can build applications that make use of all these different formats. That's no problem. But the moment that you want to combine data with all the different formats, it's likely that you have to do it at the application level. What we are proposing is that you can do this at the database level. So regardless of the source language that you use for creating applications or scripts or what have you, you will be able to have access to all these different formats across. Okay, so let's think about relational data. A very, very trivial example. Say you have three relations, three entities, the attendee, the session, and the speaker. There is one-to-one mapping, multiple many-to-many, all those things. So that's just regular. We have some properties or columns per each one of these things. We can map them directly our model to relational. We know this by heart. Now, the important thing about this is that we make sure that we have the relationships established. So that's the primary keys and the foreign keys, all those things that some of us like to do in SQL, and some of us don't want to look at these things in SQL. That's why we use ORMs. That we will prefer to use our own programming languages instead of dealing with yet another language, whether it's SQL or not, right? So the advantages of using SQL is that it's very well understood. It's been with us for a long, long time. There is a standard, have been many revisions to the standard. It's quite flexible in the sense that it's the idioms of mapping the relationships of a particular model are well known in order to put that into relational terms and then do the SQL queries. The thing that it's not really good about SQL is that you must create those mappings. You must do everything on the model and put it strictly in relational ahead of time. You have to come up with a schema. If you have a model that starts as small, you still have to do much work in just to make sure that you have these three basic relations, right? As we start adding more entities to our model, it might, you will see that, yeah, it kind of makes sense to do to work with these schemas. But at the beginning, it's like it's a little bit of a lot of effort just to get started. Now, doing the mapping of each one of these objects, sometimes it's easy to just map one object to one table, and depending on the normalization of data, you might need to break one object in the sense of a Java class, let's say this like this, into different tables. And this is where the ORMs strive to help us, so that we, as developers, don't have to look too much into how the data, the normalized data of our model is being stored. Okay. So here we have an example, again, of these 4 entities. Well, now we have 4 entities. We have the attendee, we have the speaker, the session, and we have some sort of mapping within the attendees and the session, so we know which sessions an attendee is going to go. So this will be the schedule, right? Now, from the point of view of an application, it would be great if we can have something like card like this one. So given an attendee, we know where that person is going to go. We know in which room and who is the speaker, what is the time, and where any other properties, what's the topic of that particular session. There are so many things that we can attach to this model, but it's kind of the same shape when for a given attendee, I want to have the information for session 1 and session 2 and session 3 that happen at 10 in the morning, 11 in the morning, and 12 in the morning, right? So all these session elements have kind of the same properties. So we can do this quite easily by mapping into relational, right? But if we wanted to do this in a document, there are a couple of ways that we can do this. We can start with a hierarchical model. In this case, we have at the top, at the root of our document, we have an attendee, which may have nested or embedded objects. One of those will be the session, so an attendee can have many sessions. And for each one of the sessions, there may be at least one speaker, but there can be more. So in this case, we have 3 objects nested in our document. When we look at JSON, well, it's not that difficult to understand. So here we've got the top level element, that is our attendee, and then we got the session, in which case the speaker is kind of like nested at the same level as the session. You could probably have a list of speakers or an array of speakers in the case of JSON, instead of just having one speaker. Given that this is just a single speaker, we decided to put it there. So that's the advantage of JSON. We could put it deeply nested or one level above, depending on how you want to represent the data. Or we could also do it this way. Instead of having the attendee at the root, we put the session at the top, and we make a group of both the speaker and the attendee together. So we're looking at the same data from a different point of view. Or we could do it this way. Again, depending on your use case, you would like to concentrate on who is the root of the particular document, if it makes sense for you. All right. So the good and the bad things about the document is that we can get started very, very quickly. You just come up with whoever has to be the root of your document, add some properties, make sure that you follow the JSON format, you're done. If you need nested objects, just add them whenever you need it. So given that we are schemaless, we can just add and remove and rename properties as we deem necessary. We can do it at any time. We don't have to create that schema in front and think about all the different possibilities and relationships. We're just doing things as we go. But that's also part of the problem. So once our model has continued to grow and grow and grow, we'll see that the fact that we don't have a strict schema, that we can rename things at any point in time, how do we keep up versioning, how we do migrations, how we make sure that our queries are working correctly and that something is being broken because someone decided to rename a property, or the nested object is no longer at the level that we were expecting. This is deeper instead of just one level up. These things can happen, okay? So we also do not propose to normalize JSON documents, because this is what happens. Say, in relational, we would like to strive for not redundancy of data, fully normalization if we can. But in the case of the documents, it makes sense to have some duplication of the data. Why? Because these documents are usually consumed by us, humans. They can be read by computers, of course, but it's mostly used by us because we can understand it very, very easily. But if we want to get rid of that data duplication, because if it's duplicated, we have to update it as many places as it is found, then we start to do stuff like this. We start to break down a single document, which may be big or smaller, into smaller pieces where we have to have some sort of identifiers or some other form of key or some other way to define the relationship within the different pieces and fragments of our documents. So we end up with something that looks like this. What used to be a simple document on the left side now it's the same data on the other side, but we have these identifiers and links and whatnot, and it's not really that helpful. In the end, if we wanted to map this into Java classes, you pretty much are duplicating what you have put into multiple relational tables. It's just smaller documents. So we have lost the agility, the flexibility of what documents give us, and we're trying to re-implement relational data on top of documents. That doesn't sound really nice. So that simplicity gets lost. What can we do about this? Well, the other problem that happens with normalization of data is that we get this document fragmentation. Yes, those documents look very similar, but the data that used to be just part of just one document, easy to read, easy to access, now you have to query for different places and then assemble that big document that you actually need to provide to your consumers. And that is just for reading. When you need to consume this for writing, you have one entry, one big document that has to be broken down into smaller pieces so that you can update or you can insert for the smaller segments, right? So there's additional work that we have to do at the application level. Now, so the big picture is this. When you get started with JSON, it's really fast. Most of us know JSON is very easy to digest, but as our model gets more complex, as we start adding more elements to our model, things get complicated. Whereas with relational, it is complex to get started, but as we add more information to our model, as we keep adding more elements, more properties, then we see the real benefits of just having all that structure that we have to put in place beforehand. Okay? So what we're asking ourselves is it possible to have something like this? Is it possible to have the flexibility and the simplicity of documents to get started quickly? And once we start to see that, hey, things start to get more complicated, we are adding more data, more models, more elements into our model, can we switch this thing into relational mode in such a way that we don't have to rewrite the whole application? Today, you have to choose, if I start with documents, until some point, I will have to migrate to relational, right? And that means some sort of rewrite. You have to do some re-engineering, some other stuff. There's more work ahead. What we're proposing is start with one thing and then just naturally migrate to the other. So the question is, how can we make this happen? Well, we can have both. There is no need to say, do I start with relational or do I start with documents? Once I have started with one format, I'm stuck with this one, or I have to suffer through migrations in some way. What if we can just do both at the same time? So this is what we propose with what is known as the JSON Relational Duality View. This is a particular feature that has started in the Oracle database. We are the first ones that we're doing this. It's part of perhaps our hopes that this becomes some sort of a feature that other vendors will see that it has benefits in adding. And I don't know, maybe we're talking years in the future, this could be part of the SQL standard, perhaps. We'll see. But the whole point is that you don't have to choose in front ahead of time, like, do I have one format or do I have the other? You can actually have both. So here we go. So let me show you what we have. The idea is that your data will be stored in a relational format. Because currently, whether you use Postgres or MySQL or Oracle or any other database vendor that supports both documents and relational, when you want to have this kind of the same data, you actually have to store copies of the same data, once in a document and another in relational, right? There's already duplication. What we're saying is that you store data in one way. We will choose relational, but we can expose this data as documents. So you will be thinking, Andres, that's quite simple. It's just a mapping from the relational world into something that looks like a JSON view, right? Anybody can do this. Yeah, sure. And we can do it for just one table, or we can do it for a group of tables, which means that you can create a document for just one relation, or you can create a document that encompasses multiple tables, multiple relations. Yeah, that's not a problem. And here's one way that we can do this thing. We actually have two formats. You can use JSON or you can use GraphQL. This is the GraphQL definition. On the left side, we're saying we're going to create a new kind of thing. It's called a JSON Duality View. And the name of that duality view is attendee schedule. And we start with the attendee object at the root. That is our table. That is the beginning of our document. And for this document, we're going to expose 4 properties: underscore ID, name, company, and schedule. We also have a list of objects. Each one of those elements happens to be a session object. And inside that session, we have some properties. And that session actually also has some embedded object, which happens to be from the speaker table. When we're saying with this thing, with this annotation on nest, is that the speaker, instead of being in its own objects embedded into the session, notice that the speaker name, it looks like if it was a property defined on the session object. Right? So the mapping goes here is that the first thing is that the attendee maps to the attendee name. Then we have these attendee sessions, which is also that particular table name. So the initial names of those relations map to the tables. That's good. Then for each one of the properties that we want to expose on the left side, we map which columns we want to expose from our relation. We can expose all of them, or we can be selective and say only some of them. It can even go more than that. There's even a shorthand version. For example, for company and name, we could have simply said name and company, because the name that we're going to expose matches the name of the column in the table. So there's a little bit of redundancy there. The same goes with time and room, but you can notice that for code, we're mapping the SID column name in the relation, and for session, we're mapping the S name. Okay? What else can we see here? There's a question over in the back.
Yeah, so this is indeed a view. The tables already exist at this point.
This is a view of, so the question is, this is a view of what is exists right now in the table itself?
And so the tables on the right,
yes,
already exist before. This statement doesn't create a table.
Right, so the question is, does this statement create a table? No. This is a view based on the existing structure that you already have. So the tables, attendee, session, speaker, and the relation attendee sessions must exist before. Yes, right. So this is a good catch. So the other thing that we can see here.
As relational tables, not as documents.
So the question, do they exist as relational tables? Yes, they must be relational tables to begin with. And what we're doing with this mapping is tell the database, I want you to create a document with these characteristics. So we're saying the root of the object will be attendee and all these properties, but also notice that for this particular map in the schedule, we're saying if I'm given a document that matches this structure, I want you to have the possibility to delete the relationship, or if you're trying to insert a new document, which will be a new row, I also want you to have the capability to do an insert and update. So this is the other thing that I wanted to get to. It's easy to say I got relational data, different tables perhaps, and expose that as a single document just for reading. But what happens on the other way back? What happens when we want to write, when we want to insert a new thing, or we want to update a new thing? At some point, given that this data is stored in relational, someone has to do some sort of mapping into the document to the relational world, right? Well, that someone is once again the database. You don't have to do that. You don't have to do it at the application level. And so in the end, we have a document that looks like this. It's a JSON document, but the relational data is still behind it. So you can issue SQL statements to talk to the relational table as is, and then suddenly do a query to grab that JSON view, and you will get the updated results. You can also issue a SQL query to update, to insert, to delete, and get a document out of that. But now you can also get a document as an input and do an insert, or do a delete, or do an update by just sending the document. You don't have to do the SQL statements here. The database will do it for you. You can do it in this way. On the one side, there is a simple SQL query. The JSON document will be available through a JSON column called .data, or at least that's how the view will see it. So once you are at that point, S will be the name of your relation, your view. Data is the starting point of your document, and name is the first property of the root object, which we know has to be the attendee. And we can navigate that structure using JSON path. We can apply JSON transform. We can apply any JSON functions X that the database exposes. Or we can use the other example. We can use document functions on that data as well. So in the end, what we're saying is that if you are building applications that typically work in a REST fashion, so in REST, it's so common that we take payloads out of that formatted as JSON, we craft those payloads in the application and send them to the client, the browser, the mobile, or those clients will generate some JSON payload, and we have to put it back through the application into the database. So what we're saying here is that the application can send the JSON to the client, and the client can send that JSON back and send it directly all the way to the database. If the document that is being sent has the right syntax, the right format, the right structure, then the application will do the right mapping for us. You are still, of course, have the choice that at the application level, you can modify the document if needed be for whatever reason, and then continue sending it to the database, also on the same way back. Okay, so the advantages of this thing is that if you are already consuming or thinking of consuming JSON documents, then the database can create those documents for you very easily. And you no longer have to do these kind of mappings from JSON into Java objects to figure out if it has the right format, if it's valid JSON, if it conforms to a particular structure or some sort of schema, and then send it to the database. You could simply grab that document and send it to the database, and if it matches the structure, it will do the right thing. But it doesn't, of course the application is going to blow up. I mean, the database is going to tell you, hey, this thing is not a JSON thing, or the thing that you send me does not conform to the JSON view that I was expecting. So some property was not mapped correctly, or is missing, stuff like that. And that obviously we will have to handle at the application level, because instead of doing the validation at the application level, we just told the database to do it for us. Okay, so let me show you a thing that is now typed. Oh, before I go there, let me show you how we can do this thing. If you didn't know, the latest version of the database is called 23AI. There are three versions of the three editions of the database. There's Enterprise, there's Standard, and there's the free edition, which was released April of last year as an early access for developers. This is the first time that Oracle is doing these kind of things. We're putting the database software available readily first for developers, not for the DBAs, not for the other people that used to care about. Now we care more. We care about all of you, obviously, but we care about the feedback that you developers can give us. So you can get this for free. You can put it in development. You can put it in test. You can put it in production for free. Yes, exactly. Now, You can run it for Linux, you can run it for Windows, or you can also run it as a Docker container. We also have the autonomous database. This is the version that runs on the cloud. It runs on OCI on Azure. It has the same features. It has JSON, it has vector data support. It has so many different things. Now, you could sign up for OCI. There is a free tier, which includes 2 instances of the database for real, full access to all the features of the database. We're not joking. And you get access to this thing forever. All the free resources are accessible to you. We will not charge you for anything as long as you are in the free resource tier. That's pretty cool. You can have access to that autonomous database as a container, or you can, this is the official Oracle registry for Docker images or container images. And we have a few of those. In the case of the database, we have the autonomous database free, and we also have the free edition here. So you have different options to select from. We have some community contributed images. This is hosted on GitHub. Jay Bensel, his name is Gerald Bensel. He works for Oracle. He's my manager. So we're doing this in the right now outside in the community. And this particular version of the database free, which is right now matches the latest edition 23.4, these images start much faster than the official ones. These images take about 900 megabytes, where the official ones go about 8 gigabytes, I believe. And these images usually start under 10 seconds, very quickly for a full Oracle database. This again goes for version 23, and there is, if for any reason you need to go lower, 21, 19, 18, or all the way to 11, then you can use this one as well. This also starts very fast. Although these particular versions do not have the feature that we want to dispose today, which is JSON Duality View. That's only available from 23 onward. Now, given that we're talking about Docker, you might be inclined to run real test cases against real database software using test containers. So who doesn't know what test container is? Okay, so all of you know what test containers is. Perfect. So you know what I'm talking about. We have a module that allows you to just consume any Oracle image, whether it's a free one or the XC. That is, instead of you having to create a generic container and set up some basic features or properties, the Oracle free module just do it for you. So it's much easier to get started. All right, so let's look at the demo. And what I have here is a Micronaut application, and I expect that most of you know Spring Boot. So one thing that I want to say about the different frameworks that we're working with, whether it's a Spring Boot, whether it's Quarkus or Helidon or Micronaut, is that most of the behavior exposed by these frameworks or proposed by this behavior by these frameworks is quite similar. Some of the annotation names are the same, but the packages may be different. Some of the base classes will be different name, but the behavior itself is kind of the same. So if I'm showing Micronaut and none of you know Micronaut, don't worry. You will be able to see where the mappings go into your mind, whether you want to go into Quarkus or Spring or just Jakarta. So in this case, I have an application for which I have some entity classes. This is just regular ORM mapping. This is Micronaut data, very similar to Spring data. So we have an entity that's an annotation that says I want to map this thing called a class, so that will go into a class table, and I have some properties. Some of them will be not null, so those will be the constraints, and I have a generated identifier that could be seen also for the other entities. So again, that's not much of a different magic. I have, following like in Spring data, Micronaut data has this idea of repositories, interfaces that expose basic behavior such as CRUD, create, read, update, and delete, and all kind of finders. So in this particular repository for classes, we had two finders. One way that we can find a class by name, and then the implementation will be given by us by the framework. And we have another finder that finds a given name on a list of objects. we may have a look at the different repositories, and eventually we have to figure out what is going on with our given application itself, like this one. Here we have a controller. This is the entry point of a REST endpoint, which goes into /students. For each one of the methods, we're going to expose whether it's a get, or it's a post, or it's a put, or a delete. Micronaut uses these annotations. I know that Quarkus and Spring use different, but the idea is basically the same. We expose different smaller endpoints based on method mappings. So the find by ID method will map to /ID when we do /students /any number. Okay? And in this case, we're asking for any method that I'm looking here in the repository, if it has a dv prefix, that is going through a JSON duality view. If I'm asking a repository for some other method, then, for example, that find by ID over there in line 54, that's going to the regular ORM, that is Micronaut data. So let's see what we have here. When I ask for an object for a student by ID, I give it a number, but I get as a result a string. That string is the JSON document. Notice that the repository just gives me the data as is. I don't have to do any kind of mapping because the expectation is that the client will consume that JSON object. Same goes with the find all elements. I just ask the repository, give me everything, and I get what? A string that will be a big document containing different smaller students or whatever it is in this case, right? When we want to, here are two ways that we can update a grade. So just one property of a given student using the regular ORM, which means we take some input, we find an object in the database, given in this case the ID. If we find it, then using regular Java APIs, which is what we expected for an ORM, which we update any properties, we invoke the update method in the repository. I know that Quarkus uses the, it's not anemic domain, so you can do the save directly on the entity. And then we return the thing. Whereas, if you use the JSON duality view, we get the inputs, we send those numbers directly to the duality view, and then just return an object, right? We are expecting the JSON duality view to generate an appropriate JSON document that updates that given property. I will see that in a moment for that repository. So that would be this one. When we update an average grade for a student, it starts to look a bit verbose because we're doing SQL and JSON mapping together. So that would be the data element that we see in line 21. We're saying, hey, I know that you have a JSON duality view with that given name, student DB. I'm going to show you in just a moment. And I want you to update just one property of that document. And how are you going to locate that document? Well, I know that you have to have an underscore ID at the root. So I pass you those properties, those values, and then you do the right thing. We can do the same thing for the student name. If we want to find one document by ID, this is what we do. We find everything on that document. So we select all the data from the JSON duality view found by when we find a particular matching ID. Or we can do it by name, or we can do a delete, or we can find all the average. So we are applying here just regular SQL functions. We can max, we can min, we can average, we can apply anything you want to, because this is just data as it resides in the database. All right, so enough of this. So the gentleman on the top asked, what about these tables? Do these tables have to exist early on? Yes. This is just regular DDL for creating 4 tables. And once we have this migration, I'm using Liquibase, I can apply this second migration, where I can showcase 2 different formats to create 2 different JSON views. The first JSON view is it will expose a student plus its classes and the room. So this is a schedule. These are 3 tables coming together in one document. Whereas the other JSON view that we have here, that I'm using the GraphQL format, then I'm simply saying I want to, no, this is also a schedule as well, but this is using GraphQL. I guess we are exposing what, 3 properties for the student, and we have an array of classes, and for each one of those classes we want to map what, 4 properties, and we have an embedded teacher as part of the class, but we want to put the 2 properties of the teacher at the same level as the other classes. So in the end, we will have an array of objects that have how many properties? 6 properties. All the 4 class properties and 2 of the teacher. And the last bit that we see in line 35, I think this is the mapping, the ID of the mapping within what is a class and what is a student. Okay. So now let me run this thing. So I go into the, where's my application? Here we go. There it is. I'm running my database on Docker. I think I have, there's the dashboard. Yes. And I'm running this container. Is it running? I think I'm gonna run it. That's not the one I want to run. This is the one I need to run. 23.4. Here we go. Right? So it's currently in use. What is it? This is the one I need to run. Yes. There we go. So I'm starting the database, and should take you just a little bit of moments. Did I do something wrong with this? It should have started already. Hold on a second. Oracle, that's what I'm doing wrong. I'm doing something wrong here. Oh, that's not the one that I need to run. This is the one I need to be running. Run a new container. Yes, I want to run a new container. Here we go. Hello. One thing, if the demo doesn't break, then you know that it's not live. That's the thing that I said. I'm doing something silly here, and I cannot tell what I'm actually doing. Hold on a second. I will figure it out. I'll figure it out. This is not the one I'll be running. Yes, stop this. I don't want you. You're doing something that you shouldn't be doing. Yes, and I want to run this one. Come on, do it. Strange. Except running directly from the image. Yeah, no, this. I was running it correctly. Yes, this is the one I'll be running. Come on. There we go. So the database is there. And it took, the database is ready. So I was doing the right thing. Yeah, I freaked out. So here we go. So we run the application. Come on, IntelliJ. Where is it? There you go. It's a Micronaut application. Get started very quickly. And I got a server that is running right there. I can go into the terminal, make it a bit bigger, like this. That way, so you can see it. And in the README for this particular thing, it says, okay, let's query all of the students. So when we do this query, if we go back to the controller, that means it's going through this one, which means it's going to query through the JSON Duality View. Okay, let's see if that's true. We got some JSON. Let's make it this a bit better. So let's go through JQ and less. And then we have our JSON document. Again, relational data that has been mapped as a document. Cool. All right. What else can we do? We can, let's see in the README, we can ask for one of these elements. Do we have ID number 1? Yes, we do. So I can say, oh, that's not what I want. Come on. Let's make this a little bit bigger. We can query for the first one and do JQ. Yep. That's not the correct one. We don't have that ID. Oh, invalid character. That? And what I'm doing wrong? It says SQL invalid character after HTTPS. Whoa. I have a non-breaking space somewhere. No, that's not here. I'm doing it definitely wrong. Hold on a second. We don't have to do with this one. What if we wanted to insert? Here we go. Oh, no, actually, let's try to change an average one. We have we have a student that is ID 1, right? Which is this one. And Dennis. Right now, he has an average grade of 8.5. So, if we do this, we should change it to 9.8. There we go. And we query all of them as we did before. We can see that Dennis has that update. But if we issue a similar call now using the JSON Duality View, this is the REST endpoint that was mapped. This goes directly to that transformation that I showed earlier. And then now I'm going to say, no, you're going to 8.4. And now it's not working. Interesting. And the error says, I don't get the information I wanted from this error. And very poorly with this demo, so we're going to give him an average grade of 0. And he should be really good at handling databases. Well, we don't have English class. Sorry. We're just going to be sure that he is good at math, hopefully. So we're going to post this. And let's see what happens. With this demo, so we're going to give him an average grade of 0. And he should be really good at handling databases. Well, we don't have English class. Sorry. We're just going to be sure that he is good at math, hopefully. So we're going to post this. And let's see what happens. Boom. We get a new object as a JSON document. So when we query once again all of them, we should get a new element at the end. There is, with a new ID. So with this, I prove that I can send a document all the way to the database, and I can get it back just as a JSON document. But if I were to query the database directly, this data is stored in a relational format. All right. Perfect. So with most of the technology that you have seen today and at this conference, I'm pretty sure that you have faced this. You say, oh, that kind of makes sense. I want to make use of that. But my teammates do not allow me to do this because reasons. Or my manager doesn't want to do this because reasons. Don't be discouraged. Really try out the things that you have learned today and the other days of the conference. And if you can, create a proof of concept. Do some sort of presentations to your teammates, to your colleagues, to your manager, and so that you can showcase that it is actually value of all the things that you have learned at this place, at this conference. We have some resources for you. The first link contains a list of many things that Oracle puts out for free for developers. It's not just the database that we saw, but there are other projects that some of them happen to be open source. Some others are just free but commercial or closed source. We have links to tutorials. We have links to videos. There are many things that Oracle puts out for free for developers. And we also have this as a reminder. Sign up for the free Oracle, the always free tier for the Oracle Cloud. You won't be disappointed. And we also have the database available for free. Okay? It's easy to get started. So with this, thank you very much for your time. I think I still have like one more minute for questions in case that you have them. So thank you very much. Is any question in the audience?
So I have a question.
I have a question.
You were saying that you see this curve that starts out like this and then it goes like this. So now I already have 10 million documents in Mongo, and how do I get them into the relational?
So the question is, when I was showing early on this graph, when we start very quickly with documents, and I have like thousands of documents in Mongo, how do I move this to migration? Really good question, because another thing that Oracle since version 21, but now obviously in 23 adds, we have a Mongo API compatibility layer, which means you can put an Oracle database as part of a Mongo cluster and replicate that Mongo data into Oracle, and that data will be stored as JSON documents. And once you have it in your relational space in Oracle, then you can continue using the JSON Duality View and enhance your documents with relational data in case they will be needed. Another question over there.
I have a question about performances. How does this JSON plus relational works on millions of records?
So the question is about performance. How this JSON Duality View works on millions of records and millions of properties and data. Pretty good, because that's one of the things that why we're trying to do this, or why we're doing this at the database level, so that you don't have to do it at application. The way that we can Oracle doesn't have problems dealing with amounts and lots of data.
I know. This is why I was asking. I wanted to ask: is this view also materialized view?
So the question is: are these materialized views? No. This is a brand new set of views.
I have a question.
Yes, another question.
If it's a view and if you have a lot of updates to the underlying table, will it impact the views? Will you have delay of the view to update?
So the problem, so the question is, what's the time between the updates of the views and the actual table? So for this particular one, as far as I know, I don't know if the right thing to say will be latency, but the time that it takes for the optimizer to break down that document, to figure out what needs to be updated and break it down into the SQL queries that may be issued to update whether it's one table, one column, or multiple tables. The optimizer is pretty good at this one. I cannot give you proper numbers because it will depend on the use case, on the amount of data. What I could suggest to you is that if you give a try to the free version of the database just to get started, and create a proof of concept based on the amount of data that you're expecting to deal with, and then you do your own measurements. Any other questions? Yes.
I believe in the benefits of the product, let me say that right. But if you look at this graph, you're saying that JSON is you use it in the beginning because of the use case complexity, that's small. But on the other hand, you have to have already thought about the table structure to start using this view. So for me, this slide doesn't really is correct for the kind of application you have.
Yeah, so the thing is that this graph really doesn't map the things that I mentioned within the simplicity of schema-less documents versus a schema relational. Well, you can start with a document. The way that you can do JSON mapping with relational, you can have a JSON column, and that JSON column can contain the full document as you start with, and that document may or may not have the schema as you will evolve it as you want to. And once you start with that thing, it's just a simple relational table with just one document on it. And as time goes by, you may extract properties of that document as real relational columns. So in that way, you can start very quickly there with just simple documents and start moving closer into much more relational storage. Okay, well, thank you very much for your time. Keep enjoying JCON, and see you later.